Welcome back to another math video here at Math Rocks with Mr. Cox. This video is about functions and inverse. So here we have a function f of x equals 4 times the quantity x plus 2 squared and then minus 7. And we're going to be looking at how would you make what's called an inverse. So we have some inverse notation here. You'll see a 7, a 4, a 2, a square root. Kind of similar to what's going on up here, but definitely different. So how do you come up with this equation? How do you graph it? And also domain and range. How would you calculate that as well? So stick around and find out. Let's get it on. Let's go ahead now and take a look at how inverses work. I've already taken a pretty simple function over here, f of x equals 2x minus 3, and gone ahead and graphed it. So I plotted 0, negative 3, 4, comma 5, and 2, comma 1 over here, creating a line. So not terribly exciting here, but let's talk about how inverses are created. First of all, f of x is kind of synonymous here with y, and an inverse is going to work like this. Wherever you see a y in this equation, you're going to put an x. So I'm going to write over here x equals, and then wherever you see an x, you're going to put a y. So it's going to be equals 2y and then minus 3. So this would be the inverse of the function f of x equals 2x minus 3. Then we want to go ahead and solve for y. So I'm going to go ahead and do that. So I'm going to add 3 to both sides. So now I'm also going to reverse here. So I'm going to put the 2y on this side over here on the left and x plus 3 over here. And then finally what I would do is I would divide both sides by 2. So now my function would look like this. Y equals x plus 3 all over 2. And rather than writing y over here, there is some notation for what an inverse looks like. And an inverse looks like this. F with a negative 1 and an x. And then it would be x plus 3 over 2. In terms of graphing, check this out. So I'm going to go ahead and make my t-table right here. And I'm going to put x and y here. And I'm going to plug in a negative 3. If I plug in a negative 3 plus 3 is 0. 0 divided by 2 is 0. I'm also going to plug in a 5. If I plug in a 5, 5 plus 3 is 8. 8 divided by 2 is 4. And then I'm also going to plug in a 1. If I take 1 plus 3, I get 4. 4 divided by 2 is 2. And I could graph these points right here. But before we do that, I want you to take a look at the difference between the coordinates that we use for each line here. They're the same, except over here in the inverse, they're reversed, which shouldn't be very shocking because what we did up here is we said y is x and x is y, and that's what's going to happen in the coordinates. So I'm going to go ahead and graph those right now. So negative 3 comma 0 is right here. 5 comma 4, 1, 2, 3, 4, 5, 1, 2, 3, 4 is right here. And then we also have 1 comma 2. I'm going to go ahead and do my best impression of a ruler right here. I'm going to go ahead and graph that, and there it is. That would be our inverse. And also one other little aside here, I'm going to go ahead and I'm going to draw on the line y equals x. So if we draw on this line y equals x, it's going to go through some points kind of like this here. It's going to look basically a 45-degree angle here. So I'm going to go ahead and draw that in once again as best I can. I'm going to try a few more points here, a couple more up here. And so this is my best impression of a ruler once again. So I'm going to go ahead and draw that in. And what you'll notice is that these functions, the original function and its inverse, actually reflect over the y equals x line. That's the green line right over here. And that's true for all functions and their inverses. So that's really the basics of how inverses work, is reverse x and y. You can go ahead and you can solve for y once you do that. And then they'll have the same coordinates, except on the inverse, they'll just be reversed. So it turns out there's actually another way to come up with the equation. And if you look at the function here on the left-hand side, once again, we have f of x equals 2x minus 3. What happened was we took x originally and multiplied by 2 and subtracted 3. And the way the inverse would work is we take the last step, which is subtract 3, and then we actually reverse it. So what's the opposite of subtracting is addition. So we would add 3 instead of subtracting 3, and we do it first instead of last. And then whatever we do first, we're going to do last. So the opposite of multiplying by 2 would be dividing by 2. And so if I were to write out f negative 1 of x, there's inverse, that's my notation. I would literally take x and I would add on 3, and then I would divide by 2. And if you recall, that is the same equation we came up with earlier when we just went ahead and reversed the x and the y and then solved for y. So this is another way to do it. Let's look at a more complicated one over here. Originally in this function, you would add 2, then you would have squared it, multiplied by 3, and then finally subtract 5. So the last thing is subtract 5. So the first thing in our inverse is going to be, we're going to add 5 instead of subtracting 5. We multiplied by 3, so now we're going to divide by 3. We're going to do the reverse again. Squared, well, what's the opposite of squaring? Well, that is square root. And then finally, the first thing we did is going to be the last thing, but reversed, and that's going to be subtract 2. So if I write out my inverse notation here, I'm going to go ahead and I'm going to take x, I'm going to add 5. I'm going to go ahead and I'm going to divide by 3. I'm going to go ahead and square root. Here's my square root. And then outside I have a negative 2. And if I want to, what I can do is I can plug in a point to see if this actually works or not. So I'm going to go ahead and do that. So if I go to the original function up over here, and let's say I said x was 0. What should happen is if I plug this in, 0 plus 2 is 2. Let's see, 2 squared is 4. 4 times 3 is 12, and 12 minus 5 is 7. So if done correctly, if we plug in a 7 into his inverse, we should get a 0. So let's try that. What is 7 plus 5? Well, that is 12. 12 divided by 3 is 4. The square root of 4 is 2, and 2 minus 2 is 0. So that's a quick and easy way to check to see if you did it correctly. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. We're going to go ahead now and take a look at a more difficult function than the one we used before. This one is f of x equals the square root of x plus 2, and then minus 4. I've gone ahead already and drawn the graph over here and done some coordinates. So I used negative 2 as my initial x1 because when I plug that in here, I'm going to get 0. And of course, 0 minus 4 is negative 4. If you plug in a negative 1 plus 2 would be 1. And then the square root of 1 is 1, 1 minus 4. So all of these are the coordinates that would be derived from this equation here. So they're drawn in over here. We have a domain. Our domain is x is greater than or equal to negative 2. So the furthest left this graph goes is an x value of negative 2. And anything greater than that would work. Range, similar. Negative 4 is as low as we go. So any value of negative 4 or higher would work. Let's go ahead now and let's look at the operations that created this function. Well, the first thing happened to x was we added 2. The second thing was square root, and then the third thing was we subtracted 4. So now when we switch over to the inverse, we're going to reverse this out here. So the last thing we did was subtract 4. So the first thing we're going to do is we're going to add 4. Second thing was square root. So now we're going to go ahead and we're going to square. And then the last thing was the first thing now reverse, so we're going to subtract 2. So that means our inverse should look like this. We're going to take x and add 4. We're going to square it. And when we do that, put a square there. Make sure you put parentheses around x plus 4 and then put a subtract 2. As far as coordinates go, let's go ahead and make a t-table right here, x and y. I'm going to use negative 4 as my first x coordinate. And the reason why I do that is, remember, these are going to get reversed here. So if I use a negative 4 plus 4 is 0, 0 squared is 0, 0 minus 2 is negative 2. And so it does confirm what we already know. Let's go ahead and use this y as our next x. Negative 3 plus 4 is 1. 1 squared is 1, 1 minus 2 is negative 1. So I'm just going to go ahead and do the next two coordinates and just reverse them here. So negative 2, comma 2, and then negative 1, comma 7. And that's okay. You don't have to actually calculate them out. But we just know. You just reverse them. I'm going to graph them now. So negative 4 and a negative 2 would be right here. Negative 3, negative 1 would be right here. Negative 2, comma 2 would be up here. And then negative 1, comma 7, let's see, 1, 2, 3, 4, 5, 6, 7. And And then I'm going to go ahead and connect them into a curve that looks something like this. And so there you have it. That would be the inverse of f of x. And as we already know too, if you draw in the graph of y equals x, and I'm going to do that in blue here. Let's see, I'm going to pick a couple points here, and I'm going to pick a couple points over here too, and it's going to go through the origin. Let's see this one over here. So here's my best impression again as a ruler. It's going to go something like this. And these functions are reflections over the line y equals x. Last but not least, let's take a look at the domain and range of our inverse. If I look at our domain, that means what can x be? Well, if we look at here, that would be x is -4, and any value greater than that would work. So x is greater than or equal to -4, and then if we look at the range, that means, let's look at the lowest it goes. Well, the lowest it goes is a y value of -2, and anything bigger would work, so that would be y is greater than -2, and lo and behold, you'll notice the domain and range for the inverse look strikingly similar to the ones for the original function. They're just reversed. The -4 is now part of our domain, and what was in the domain up here is going to be part of the range. So that will hold true as well. So you guys, that's it. That's everything you need to know about functions and inverses. Thanks for watching.